A body moving with uniform acceleration has 2 points 5, 15. Please pay attention. A body moving with uniform acceleration has 2 points 5, 15 and 20, 60 on the velocity time graph of its motion. We are asked to determine the uniform acceleration. Okay, please, I want to pay attention. Let's start by let's draw the graph. Okay, let's draw the graph. We have this. We are given 2 points. The first point is 5, 5. The first point is 5, 15. Sorry. And the second point is 20, 60. Okay. Now, I want to pay attention. I'm very sure you learned about coordinate geometry. You understand? At every point we always have x, y. You understand? X, y. That is x, y, and this also is what? X, y. That is for the first point, x1 is what? X1 is, this is x1, okay, and this is y, okay. For the second point, this is what? X, and this is what? Y, because on every point on the graph we always have what? X, y. Do you understand? Okay. Now let us plot this point on this graph. You understand? This will be what? X1, and this will be y1. This will be x2, and this will be y2. Do you understand? Okay. Now for x1, let's say this is point 0, 0. Okay. Now for x1, this is the x-axis. You understand? This is the x-axis, and this is the y-axis. This is the x-axis. Now for x1 we have 5. Of course, 5 is greater than 0. You understand? Let's say it is 0. This is where I'm going to have the x1. But the first coordinate for x1 is what? 5. You understand? Now for y1 we have what? 15. So let me put 15 here. Please, are you paying attention? I'm just trying to plot the point. You understand? I'm just trying to plot the point. We are asked to calculate the acceleration for the uniform. We are asked to calculate the uniform acceleration. You understand? So I'm trying to plot the point on the graph because we are dealing with velocity time graph. Do you understand? So let's plot x2. X2 is 20. So let's say we're going to have 20 here. You understand? And y2 is 60. So we're going to have something like here 60. You understand? Now let us look. When x1 is 5, what is the value of y1? Y1 is 15. So let us trace it. Let us trace this also. So they meet at this place. So let us draw the point. And we raise this now. Are you paying attention? Please pay attention, okay? And then for the second point, which is 20, 16, x2 is 20 and y2 is 60. So let's draw the point again. Let me draw the point upward for the x2 now. Don't mind this thing. I'm not using graphs. You understand? Okay. And for y2, okay, this is where they meet. They meet at this place. Let's draw the point. You understand? Now we have plotted all the coordinates. You understand? Now we are asked to determine the acceleration. The acceleration of the uniform acceleration of velocity time graph is the slope. You understand? Don't forget, in our previous class I told you slope is associated with what? Division. You understand? So the uniform acceleration of a velocity time graph having 2 points is what? Is the slope. Do you understand? Now the slope, let's draw the line. The line for the slope is here. You understand? So we want to calculate the slope, okay? We want to calculate the slope. I just represent as AB, that's the line, okay? Now, don't forget in your coordinate geometry, slope is always represented as what? N is equals to what? Y2 minus Y1 all over X2 minus X1. Or change in y all over change in x. Do you understand? I'm very sure you remember this formula very well. Okay, we are still going to use the formula to determine the uniform acceleration. You understand? So let's calculate the slope of AB. The slope of line AB is equals to change in x, change in y, all over change in x. So I'm going to have y2 minus y1. y2, please, I want to pay attention. y2 minus y1 is what? y2 is 60, you understand? So I'm going to have 60 minus y1. y1 is 15, so 60 minus 15 all over change in x. Okay, let me erase this. All over change in x. Change in x is what? That will be 20, which is x2. Please pay attention. x2 minus x1. Okay, so 20 minus 15. 20 minus 5 rather. Now 60 minus 15, that is 45. Okay, so I'm going to have 45 all over 15. So 45 divided by 15 is what? 3 is 3. And acceleration is measured in meter per second squared. Do you understand? So I'm going to have 3 meter per second squared. Do you understand? So that is the uniform acceleration. That's the uniform acceleration that we're asked to calculate. Now, please pay attention. On a velocity time graph, the uniform acceleration is equals to the gradient. That's the major point I want you to hold. Okay? On a velocity time graph, the uniform acceleration A is equals to the gradient or the slope. You understand? Or the gradient of the graph or the slope of the graph. You understand? The gradient is also the same thing as slope. Okay? So, question 2. A car starts from rest at a checkpoint A and comes to rest at the next checkpoint B, 6 kilometers away in 3 minutes. It has first a uniform acceleration for 40 seconds. Then a constant speed and is brought to rest with a uniform retardation after 20 seconds. Sketch a velocity time graph of the motion. That's the first question. Then we are asked to determine the maximum speed and the retardation. This is NECO 2003. Okay. Welcome to another class on motion graph. In today's class, we're going to solve questions on this concept, velocity time graph. Okay, let's start with the first question. A car runs at a constant speed of 15 meters per second for 300 seconds and then accelerates uniformly to a speed of 25 meters per second over a period of 20 seconds. This speed is maintained for 300 seconds before the car is brought to rest with uniform deceleration in 30 seconds. Draw a velocity time graph to represent the journey described above. And from the graph, find the acceleration while the velocity changes from 15 meters per second to 25 meters per second, the total distance traveled in the time described, and the average speed over the time described. Well, what an interesting question. Okay, let's start by drawing our graph. Okay, we have our graph here. Now, please, I want to pay attention, okay, because this question is technical. Now, a car runs at a constant speed of 15 meters per second for 300 seconds. You know, since we are dealing with velocity time graph, we are going to have velocity in meters per second and time in seconds. We're going to have time here, time in seconds. Okay. Now, the car runs at a constant speed of 15 meters per second for 300 seconds. So here I'm going to have, let's say this is 0, 0, you understand? So now let's say this is 15, you understand? This is the velocity at 15 meters per second. So we have something here, we have 15 here, and it runs at a constant speed. That means that the speed is not changing. And I told you in our previous class that when a car or an object is moving at a constant speed, the graph look like this. You understand? Please pay attention. In our previous class, we learned this. When a body is moving with a constant velocity of speed, this is how the graph will look like. So now we are told in the question that the car runs at a constant speed of 15 meters per second for 300 seconds. So now here I'm going to have a distance look like this. don't mind the diagram, okay? I want to sketch out the diagram now. Now here will be 300. The distance from this point to this point will be 300, okay? 300 seconds. Do you understand? Okay, now let us proceed. And then accelerate uniformly to a speed of 25 meters per second over a period of 20 seconds. Now, having undergo a constant speed of 15 meters per second for 300 seconds, the car now accelerates uniformly to a speed of 25 meters per second. Now, from this point, it accelerates. And I told you in our previous class that when a car accelerates, the graph look like this. You understand? Accelerate. Okay? So, it accelerates for 20 seconds. So, I'm going to have here 20 seconds. So, from here. So, now, the distance from this point to this point is what? 20 seconds. Now, if I want to calculate the distance from this point to this point, that will be what? 300 plus what? 20. You understand? That will be what? 320. Do you understand? Okay? Now, let us trace this to this point. This will be 25 meters per second. Okay? 25 meters per second. Okay? Now, let us proceed. This speed is maintained for 300 seconds. Wow, what an interesting question. After it accelerates to this point, the speed is now maintained for 300 seconds. So, and that means that the speed is constant for 300 seconds. And at constant speed of velocity, the graph look like what? This. Okay? At constant speed of velocity, the graph look like this. The speed is not changing. So for this, I'm going to have here. So now the distance between this point and this point is what? 300. Okay? That is 300 seconds. You understand? So the distance between this point to this point, that will be what? 300 plus 320 plus 300, that will be what? 620. Do you understand? Okay? Now let's proceed with the question. Now, the speed is maintained for 300 seconds before the car is brought to rest with uniform deceleration in 30 seconds. So from this point, the car decelerates to from this point the car decelerates at 20 seconds. So let's just call it is it 20? Oh, 30 seconds, sorry. The car is brought to rest with uniform deceleration in 30 seconds. So from this point to this point, it is 30 seconds. So now from this point to this point, 30 seconds. Now the total distance, the total time taken will be what? 620 plus 20. 620, which is distance from this point to this point, plus 30. You understand? That will be what? 650. So I'm going to have 650. So the total time taken is what? 650. Okay? Now, pay attention. Pay attention, okay? I want you to pay attention. This is the velocity time graph that you are asked to draw. Okay? That's the first question. If you look at that, you are asked to draw a velocity time graph to represent the journey. So you have a mark for that. Now, the acceleration, why the velocity changes from 15 meters per second to 25 meters per second. Okay? Meter per second. The acceleration, when the velocity changes from 15 meters per second to 25 meters per second. Now, please pay attention. This is the acceleration that we are asked to determine. We are asked to determine the acceleration from this point to this point. So let us represent this point as A. Let us represent this as B, C, D, E, F, G, H. You understand? Now, to determine the acceleration when the velocity of the car changes from 15 meters to 25 meters per second, we just have to make use of the formula of slope. You understand? Don't forget, in our previous class I told you that when you are asked to calculate acceleration, you are going to make use of the slope. Okay? Slope is associated with acceleration. In velocity time graph, acceleration is associated with slope. Okay? So let me sketch this. The acceleration is equal to, please pay attention. To get the acceleration at that velocity, we just have to make use of change in velocity all over change in time at that particular moment. That is also the same thing as slope. You understand? So I'm going to have change in v all over change in t. So now that will be v2 minus v1. You understand? v2 is what? That is the final velocity. v2 minus v1 all over t2 minus t1. Okay. Now v2 minus v1. v2 is 25. So I'm going to have 25 minus v1. v1 now is what? 15. You understand? v1 now is 15 meters per second. 25 minus 15 all over t2 minus t1. Now the time taken at that moment, the first time taken is what? 0. That will be 0. And the second time will be 20. You understand? That will be what? t2 20 minus t1. That is what? 0. So I'm going to have 25 minus 15. That is 10. 10 all over 20. That will be what? 0.5. So that will be 0.5 meter per second squared. That is the acceleration when the velocity of the car changes from 15 meters per second to 25 meters per second. Do you understand? Question 2. We are asked to determine the total distance traveled in the time described. See, don't forget, in the previous class I told you that when we are asked to calculate the distance in the velocity time graph, we just have to take the area of the graph that we have. You understand? The area of the velocity time graph gives the total distance. Okay. Now, but in this velocity time graph, we have many shapes. You understand? We have triangle, trapezium. Oh wait, no, this is not triangle. Sorry, rectangle, trapezium, and this rectangle and also a triangle. So we have to pay. You have to pay attention here. To calculate the area, okay, the total distance. Pay attention, okay? Total distance is equals to the area, okay? Now, the area of the velocity time graph. Now, let's start with, please, I want to pay attention. We're going to start with this, with the rectangle first, okay? We're going to start with the rectangle. That means we're going to have area of ABHO. Okay, ABHO plus, we have another area in that place. That will be what? B, area BC, that's the shape, BCGH. You see, I'm just trying to take the area of all the shapes. You understand? That is what I'm doing, okay? I want to calculate the area of all the shapes. Now, the first area here is what? Area of this rectangle, the rectangle ABHO. You understand? And the second area is the area of this trapezium. That is what? Area BCGH. That is BCGH. BCGH. Then we add it to another area of this rectangle. That is area CDFG. You understand? CDFG. This area, CDFG. Area of this shape, particularly. CDFG plus the area of DEF. DEF. Do you understand? Now we're going to calculate the area one by one. Now we're going to start with the rectangle ABHO. ABHO. The total distance from this point to this point is what? 300. Okay? And the total distance from this point to this point is what? 15. Okay? So area of, please pay attention, area of ABHO will be equals to area of a rectangle is what? Length times breadth. You understand? So I'm going to have 300 multiplied by breadth. The breadth is 15. That will be what? Length times breadth. Let me put it in this place. Okay? Please just pay attention. Okay? All I need now is your attention. Area of ABHO, that will be length times breadth. That will be 300 multiplied by 15. Okay? Plus area of BCGH. Area of BCGH, that is the area of trapezium. You understand? You know, this shape, how will I draw it? Please, I want to pay attention. We have this shape. I mean, this is a trapezium, you understand? And from this point to this point is what? That is 15, okay? 15. And from this point to this point is what? 25, you understand? That is 25. Do you understand? And from this point to this point, which represents the distance from this point to this point, it is what? 20. You can see that that is a trapezium, you understand? From this point to this point is 20. From this point to this point is the same height as this. That's 15. And from this point to this point is what? 25. You understand? So that is a trapezium. So area of trapezium is what? Half the addition of the parallel side multiplied by the height. You understand? Area of a rectangle. Area of a rectangle. For a rectangle is what? Length times breadth. Area of a trapezium. That is what? Half into bracket A plus B multiplied by height. You understand? So A and B are the parallel side. You understand? And the parallel side here is what? 15 and 25. So I'm going to have 1 over 2, 25 plus 15 multiplied by height. The height here now will be what? 20. Please, do you understand what I'm doing? If you don't understand, listen to the explanation again. It's simple, okay? So now I have CDFG. CDFG. Now, what is this shape? This shape is also a rectangle, you understand? And the total distance from here to this point is what? 25. Please pay attention, okay? It's very simple, you understand? What I'm doing is that I'm calculating the area of the figure that I have in the graph, you understand? I have rectangle, trapezium, rectangle, and triangle, you understand? So I'm calculating the area of what I have in the graph. Since area, total distance is equal to the area, you understand? So total distance is equal to the area OA, B, C, D, E, F, G. You understand? Area of the shape is equal to the total distance. So I'm calculating the area one by one. The area of the rectangle is this. The area of trapezium is this. Now I want to determine the area of CDFG. That will be what? Length times breadth also, because this shape is what? CDFG is a what? Is a rectangle. You understand? So for this I'm going to have plus area of this, that will be length times breadth, that will be 300, which is the distance from this point to this point. Look, let me draw it here, okay? We have something like this. We have something like this. You can see that this is the rectangle. You can see this is the rectangle. Now, the distance from this point to this point is 300, okay? And the distance from this point to this point is what? 25. So, for this, I'm going to have 300 multiplied by 25. Do you understand? Plus, now, we have to calculate the area of DEF. Don't forget that the shape of DEF is what? A triangle. You understand? Now, if you want to calculate the area of triangle, that will be what? Half base times height. Okay? Now, this is the base. This is the base. And this is the height. The height is what? 25. So I'm going to have half base. The base is what? The base is 30. Half base multiplied by height. The height is what? 25. Multiplied by 25. Please, do you understand how I got all these values? If you do understand, kindly reverse the video and watch it again, okay? Now, we can calculate the total distance by adding all these values. 300 multiplied by 15, that will be 4,500. So for this, I'm going to have 4,500 plus 25 plus 15, that is what? 40. 40 divided by 2, that is 20. 20 times 20, that is 400. So I'm going to have 400 plus 300 multiplied by 25. That will give us 7,500, okay? 7,500 plus 30 times 25, that is 750. 750 divided by 2, that will give us 375, okay? 375. So if you add all this together, we're going to get the area. That will be 12,775 meter. 12,775 meter. That is the area. That is the area, which is total distance. You understand? The total distance here is this. Do you understand? Okay. Now, let's proceed to the next question. The next question says we should calculate the average speed over the time described. Don't forget that this is what? Distance all over time. You understand? And we have known the total distance as what? 12,775 meter. And the total time taken will be what? 650. So the speed is equals to the total distance, which is 12,775 meter, all over the total time taken. That is what? 650. So if you divide this by if you take the division, you're going to have 19.65. This will be 19.65 meter per second. Okay, that is the speed. Okay, so we've come to the end of the question. If you have any question regarding this particular question, you can drop it in the comment box. In today's class, we're going to be considering some exam questions on this concept, velocity time graph. Okay, let's start with the first question. If a car starts from rest and moves with a uniform acceleration of 10 meters per second squared for 10 seconds, the distance it covers in the last 1 second of its motion is dash. Okay, let's draw the velocity time graph. Okay, don't forget that the question says the car starts from rest, you understand, and it accelerates for 10 meters per second squared. Please, I want you to pay attention. Okay, we've learned in our previous class that if we have a car that starts from rest, the velocity time graph will look like this, you understand. Okay, so because the car starts from rest, let's have the velocity time graph. Let this be v, and we have t in this place, you understand. Okay, now we are told that the car starts from rest and moves with uniform acceleration of 10 meters per second squared. So because the car starts from rest, we're going to start from origin 0,0, you understand. This is the origin, you understand. So it starts from where it's going to move like this, okay, for 10 seconds. So the distance between this point to this point, let's call this one 10 seconds, okay. This is too high. Let me increase this as well. I'm just trying to draw, interpret the question, you understand. So by drawing out the diagram, okay. So this will be 10 seconds. Let me reduce this also as well, okay. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You understand? And we are given that acceleration A equals to 10 meter per second squared. Okay. Now the car starts from rest. If the car starts from rest, what will be the initial velocity? The initial velocity will be 0. You understand? Because the car starts from rest. That means that u is equals to 0. Okay. Now I think those are the parameters that were given in the question. Now, please, I want you to pay attention. We cannot determine the distance is covered without knowing the velocity that it attained for 10 seconds. You understand? Please pay attention. We cannot determine the distance that is covered in the last 1 second without knowing the velocity that is covered in the 10 seconds. Are you paying attention? So I'm going to calculate the velocity. Do you understand? And since I have known that we are given that the car starts from rest, from the equation of motion, the first equation of motion states v equals to u plus at. That is, the final velocity is equals to initial velocity plus the product of acceleration and time. You understand? Now, for this, v equals to 0 plus at. A here will be what? 10. 10 multiplied by t. T is what? 10. You understand? T is 10. So 10 multiplied by 10 will be what? 100. So v is equals to 100 meter per second squared. You understand? So the velocity at this point, is what? 100 meter per second squared. Okay, 100. Okay, this is meter per second. Oh, sorry, velocity is in meter per second. Okay, sorry. So the velocity at this point is what? 100. Okay, 100 meter per second. Now, please pay attention. You know that the question says we should calculate the distance is covered in the last 1 second of its motion. That means that distance will be the distance between the 10th second and the 9th seconds. You understand? I will repeat that again. Okay, we are told to calculate the distance is covered in the last 1 second of its motion. That distance will be the distance between the 10th seconds and the 9th seconds. You understand? So I will calculate the distance for the 10th second separately. I will calculate the distance of the 9th second separately. Then I'm going to take their positive difference. You understand? that will be the distance is covered in the last 10th seconds. Do you understand? Okay, now, but this velocity is for the velocity is attained in the 10th seconds. Okay, v10th. This is the velocity that is attained in the 10th seconds. Now we can determine the velocity that is attained in the 9th seconds. How do I do that? We are still going to make use of the equation of motion. You understand? The velocity that it attained, that the car attained in the 9th seconds now. 9th seconds. V9. Okay, let me just put it V9. Please pay attention, okay? V9 is equals to U plus AT. So V9 is equals to 0 plus A. A is 10. T is now what? 9 seconds. You understand? You know, but I want to determine the velocity that the car attained in the 10 seconds. Acceleration is 10 and time is also 10. You understand? But I want to determine the velocity that the car attains in the 9 seconds. That means that T will be what? 9. You understand? So I'm going to have this multiplied by 9. So V9 is equals to 90 meter per second. You understand? So this is 90 meters per second. It will be around this place, 90. Okay, so let me just sketch this down and then let's have something like this. You understand? So now we can easily determine the distance that the car covered in the last 1 second of the motion. How do we do that? We just have to take the area of the shape that we have on this board. You understand? And the difference will give us the distance that is covered in the last 1 second. Okay, so let's start. What is the name of this shape? Please pay attention. What is the name of this shape? We have something like this for the 10 seconds. Okay, we have this, the first shape, and we have another shape. We have two shapes in this velocity time graph. Okay, we have another shape. We have another shape that looks like this. Sorry, I'm not really good at drawing. You understand? So we have the first shape and this is the second shape. The first shape is the bigger triangle. You understand? That will, from this point to this point is what? 10. So we have 10 here. And from this point to this point is what? 100. Please pay attention. Listen. We have two right angle triangle in this shape. The first one is this. The first right angle triangle is this. You understand? Please pay attention. The first right angle triangle is this. You understand? And the base from this point to this point is what? 10. That's why I have 10 here. Okay? And the height from this point to this point is what? 100. That's why I have what? 100 here. Okay? Now, let's look at the second one. The second one is the this is the triangle. For the second one, we have this. From this point to this point is what? 9. So I'm going to have 9 here. And from this point to this point is what? 90. So I'm going to have 90 in this place. Do you understand? Now, the distance that the car covered in the last 10 seconds will be the difference between this area and this area. You know that in velocity time graph, the area of the graph give the distance. You understand? So if I want to calculate the distance that the car cover, I'm going to use the formula of a triangle. You understand? Let's calculate the area for the first triangle. I'm going to have area. Okay, let's call it distance now. Okay, distance. The distance here equals to half base, half multiplied by 10 times 100. You understand? So for this, I'm going to have 2 here 1, 2 here 5. 5 times 100 is what? 500. So this will be what? 500 meter. Okay. Now for the second triangle, that will be the distance also. The distance is equals to half base times height. The base is 9. So I'm going to have multiplied by 9 multiplied by 90. You understand? So for this, I'm going to have 2 here 1, 2 here 4.5. 4.5 multiplied by 90. That will give us 405. Okay. So this is 405 meter. Okay. Now the distance in the last in the 10 seconds, that will be the distance in the 10 seconds. 10 seconds. That will be 500 meter minus 405 meter. That will be 500 meter by minus 405 meter. That is 95 meter. You understand? So that is the solution to the question. Trust you understand. If you do understand, reverse the video and listen to the explanation again. Okay? Let's have the second question. A body which is uniformly retarded comes to rest in 5 seconds after traveling a distance of 10 meters. What is its initial velocity? Okay, let's draw the velocity time graph. Don't forget that in our previous class, I told you that when a body comes to rest, the velocity time graph will look like this. You understand? Okay, that is the body retarded, it's coming to rest. It has a significant initial velocity before. You understand? For example, you can have a car moving with a velocity of 10 meters per second. Then the body comes to rest, and come to rest means it retards. You understand? The velocity begins to decrease slowly till the body comes to rest. So the velocity at the peak here is the initial velocity now. You understand? Are you paying attention? Because the body is moving with initial velocity of 10 meters per second now. I'm just assuming. You understand? So the velocity we have a initial velocity we have a significant figure because the body comes to rest. And come to rest means that it's traveling with a particular velocity before. That velocity is what we call the initial velocity. Do you understand? Okay. So when the body comes to rest, the velocity time graph look like this. Do you understand? Okay. Let's go back to the question. A body which is uniformly retarded comes to rest in 5 seconds. Let's have the velocity time graph. Okay. We have V and we have T. V in meter per seconds and T in seconds. Okay. Now, the body which is uniformly retarded comes to rest in 5 seconds. So, since it comes to rest, the velocity diagram will look like this. Do you understand? So, this will be what? 0. And because the question says that the body comes to rest in 5 seconds, so here will be what? 5. Do you understand? So, we are told to calculate the initial velocity, and they gave us that the distance covered is what? 10 meters. So the distance covered equals to 10 meters. How do we calculate the initial velocity? Please kindly pay attention. The initial velocity of this body is the height. You understand? You see, the parameters that you are given in the question will define what you are going to use. I pay attention. We are given that the distance covered is what? 10 meters. Now, in velocity time graph, the distance covered is the area of the shape. You understand? Area of the shape that we have in our velocity time graph is the distance covered. Now, what is the name of this shape? The name of the shape is what? Triangle. And the formula for triangle, area of the triangle is given by half base times height. You understand? The height there is the velocity. You understand? This is the height. Is that not it? The height is on the y-axis. You understand? And if the height is on the y-axis, that means velocity is also on the y-axis. So the distance from this point to this point is what? Is the height. That is what I'm looking for. Now, if I get the height is the velocity, and if I get the height of this triangle, that is the velocity of that triangle. Do you understand? If you understand, listen to the explanation again. In velocity time graph, the distance is calculated using the area of the shape. You understand? The area of this shape is half base times height because we are dealing with triangle now. Is that not it? Now, having known that we are dealing with triangle, half base times height. Height in velocity time graph refers to the velocity. You understand? Height in velocity time graph refers to velocity because in velocity time graph, the velocity is measured along the y-axis. So this is velocity, and this velocity is the initial velocity. You understand? Because the body is coming to rest. Okay? So let us calculate the initial velocity. The initial velocity is the height. Initial velocity U equals to h. You understand? And the area of a triangle is equals to half base times height. Is that not it? Like we did in the previous question. So I'm going to have 1/2 multiplied by base, which is 5, multiplied by height, which is h. I don't know the height. The height is also the same thing as v. Or let us represent as u. You understand? The height is also the same thing as u. You understand? So area has been given. So area is what? 10 meters. So I'm going to have 10 equals to half base times height. Do you understand? So for this, I'm going to have 10 equals to 5u all over 2. You understand? Now I'm going to cross multiply. 10 multiplied by 2 is 20. So I'm going to have 20 equals to 5u. Divide both by 5. This over 5 and this over 5. That means u equals to 4 meter per second. You understand? So that is the initial velocity of the body. Of the canal. Body is we are dealing with body. So that is the initial velocity of the body. You understand? Please, do you understand the explanation? If you didn't understand, listen to the explanation again. In today's class, we are going to be considering question on this physics concept, velocity time graph. Okay? A body at rest is given an initial uniform acceleration of 8 meters per second squared for 30 seconds, after which the acceleration is reduced to 5 meters per second squared for the next 20 seconds. The body maintains the speed attained for 60 seconds, after which it is brought to rest in 20 seconds. Draw the velocity time graph of the motion using the information given above. Using the graph, calculate the maximum speed attained during the motion, the average retardation as the body is being brought to rest, the total distance traveled during the first 50 seconds, and the average speed during the same time interval as in Roman figure 3. Okay, please, I want to pay attention here. Let's start with the first question. We are asked to draw the velocity time graph of the motion. Okay, now let's go back to the question. A body at rest is given an initial uniform acceleration of 8 meters per second squared. In our previous class, we learned that when a body accelerates, the graph looks like this. Okay, when the body accelerates, the graph looks like this. And if the acceleration is reduced, the graph will look like this. Do you understand? That is, a body is coming to rest. Are you paying attention? Because acceleration tells us how fast the velocity of an object is changing with respect to time. Do you understand? Okay, so let us draw the graph. Velocity time graph. Let's have the velocity time graph here. I don't know if my can just pay attention, okay? Please just pay attention. You understand? Okay? Now, this is the graph. We have velocity here. This is the velocity and this is the time. Time t in seconds, okay? And velocity in meters per seconds. Now, okay? A body at rest is given an initial acceleration, an initial uniform acceleration of 80 meters per second squared for 30 seconds. Okay? The first time that we are given is 30 seconds. So, let's say this is where the body starts. The body is at rest. Then, because it accelerates for 80 meters per second squared, this is how the graph will first look like in the 30 seconds of the time. You understand? In 30 seconds, the body is accelerating. You understand? Please pay attention. The body is accelerating in the first 30 seconds of the motion. Do you understand? So that is how the graph will look like. Let me, I don't want to, just pay attention, okay? The graph will look like this. Let's say this is the first 30 seconds, okay? So let us trace this downward. So for the first 30 seconds, from this point to this point is what? 30 seconds. Do you understand? Just pay attention, okay? Now, this is the first 30 seconds. Now, the question now proceeds that after which the acceleration is reduced to 5.0 meters per second squared for the next 20 seconds. The body accelerates for the first 30 seconds at 8 meters per second squared. That is the acceleration. Now, the acceleration is now reduced to 5 meters per second. 5 meters per second squared. This implies that the body velocity is also reduced. You understand? Increase in acceleration leads to increase in velocity, and decrease in acceleration leads to decrease in velocity. You understand? So the velocity at the first 30 seconds is at this point. Now, because the body changed acceleration, the acceleration reduced from 8 meters per second squared to 5 meters per second squared. Though the body is now going to look like this. You understand? So from this point from this point to this point, it decelerates. You understand? So let us call this. So from this point to this point now will be what? 20 seconds. Please, do you understand? Just pay attention, okay? This is the acceleration for 8 meters per second squared, and it decelerates for 5 meters per second squared. Are you paying attention? Okay? Now let us proceed. The body maintains the speed attained for 60 seconds. Now, having gotten to this point, when it decelerates, reduction in acceleration simply means negative acceleration. That is what? Deceleration. You understand? Okay? So, when it decelerates from this point to this point, the body maintains the speed attained for 60 seconds, after which it is brought to rest. Now, if it maintains the speed at constant speed, that is at constant velocity, the graph will look like this. I'm very sure, please, you know what? If you are, maybe you missed the first, second, and third class, you can check the playlist on this channel. You understand? Watch it to understand what I'm doing here. Do you understand? Okay? When at constant speed, this is how the graph of the velocity time graph will look like. You understand? When the speed is constant. So, because the question says the body maintains the speed attained for 60 seconds, it maintains simply means that the speed is constant for 60 seconds. Do you understand? So, for this, we're going to have something like this, 60 seconds. So, from this point to this point is what? 60 seconds. Do you understand? Now, let's proceed. After which it is brought to rest in 20 seconds. Now, having maintained this speed for 60 seconds, the body now comes to rest in 20 seconds. That means that, and I told you that when the body comes to rest, the velocity time graph will look like this. You understand? When the body comes to rest, the velocity time graph will look like this. So, we're going to have this. You understand? So, from this point to this point is what? 20 seconds. Okay, so this is how the velocity time graph will look like. Okay, let us trace this to this point. Let's trace this also. This is how the velocity time graph will look like. Now, please pay attention. We are asked to calculate the maximum speed attained during the motion. You see, we cannot determine the maximum speed attained without knowing the initial velocity. You understand? The initial velocity is the velocity here. The velocity at this point is the initial velocity. You understand? Please pay attention. We have to first determine this velocity before we can determine the maximum speed attained. You understand? The maximum speed attained is the speed or the velocity after the body has undergoes retardation. You understand? The maximum speed attained is the speed of the body after it has undergone retardation. You understand? Now, before it undergoes retardation, it attains a velocity. That velocity becomes the initial velocity at that point. You understand? See, this is very simple. All you have to do is just to pay attention. Your ability to interpret this question matters a lot in this case. Look, we are told that the body starts from rest. Now, if the body starts from rest, and we want to determine this velocity, please pay attention. We first need to determine this velocity. And to determine this velocity, we are going to use the first equation of motion. You understand? V equals to U plus AT. You understand? Now, when the body accelerates from this point to this point, the acceleration is what? 8 meters per second squared. And the time taken is what? 30 seconds. So, V equals to 0 plus 8 multiplied by 30. You understand? Just pay attention. V equals to 0 plus 240. So, V equals to 240 meters per second. So, the velocity here is what? 240. You understand? This is the velocity here. Now, when the body accelerates from this point to this point, the velocity is 240 meters per second. But that is not the maximum speed. You understand? The maximum speed is the final speed after the body has undergone retardation. You understand? Now you can see that the body retards from this point to this point. So at this place will be the maximum speed. The speed at this point is the maximum speed. You understand? Because that is the speed or the velocity after the body has undergone retardation. You understand? Okay? Now, to get that speed, we are still going to use the equation of motion. Do you understand? To get the speed here, we still have to make use of equation of motion. The first equation of motion is what we are going to use. Now, don't forget that If this now become v, this will become u. You understand? Please pay attention. The maximum speed is also the same thing as what? The final velocity. Okay? Now, if this now becomes the final velocity, the velocity before there will be the initial velocity. Do you understand? Okay? That is why I said we cannot determine the maximum speed or the maximum velocity without knowing the velocity that it attained here. You understand? So, the velocity that it attained here is what? 240 meters per second. Now, we can easily determine this using the equation of motion. Don't forget that v equals to u plus at. V equals to u. U is now 240. So I'm going to have 240 plus a. Now, please pay attention. You can see that the body is decelerating. You understand? The body is decelerating. Therefore, a will be negative. You understand? The acceleration will be negative. It decelerates from this point to this point. So we are going to have negative acceleration. Okay? So in this case, I'm going to have a is equals to negative 5 multiplied by the time is what? 20. If you didn't understand, listen to the explanation again. Don't forget that in the question, we are told that the body having attained this velocity, having accelerated for 8 meters per second, it now the acceleration reduced to what? 5 meters per second. That acceleration is what I call retardation or deceleration. You understand? Because the body changes, that is negative acceleration. Because that is the kind of acceleration that reduces the motion of the body. You understand? So that is why I have negative 5 in this place. Okay? So V equals to 240 minus 100. V equals to 140 meter per second. So the velocity or the maximum velocity here is what? 140. Do you understand? Okay, so let's proceed to the next question. The next question is to determine the average retardation as the body is being brought to rest. Now, in this velocity time graph, you can see that the body is brought to rest from this point to this point. You understand? So the average retardation will be change in velocity at that point and over change in time. You understand? And the velocity at that point is what? 140 and what? 0 meter per second. The time at that point is what? Oh, sorry. I think we have to do something here. From this point to this point is what? 30. Now, from this point to this point will be 30 plus 20. That is what? 50. From this point to this point is 60. So 50 plus 60 is what? 110. You understand? Now, from this point to this point is what? 20. 110 plus 20 is what? That is 130. Okay? Do you understand? If you do understand, pay attention again. You know, from this point to this point is 30. So I have 30 here. From this point to this point is what? 20. So if I want to calculate the time taken from this point to this point is what? 30 plus 20. That's why I have 50. Now, from this point to this point is what? 60 seconds. If I want to calculate the time taken from this point to this point, I'm going to have 50 plus 60. You understand? So I have 110. Now, from this point to this point is 20 seconds. If I want to calculate the time taken from this point to this point, I'm going to have 110 plus 20. That's why I have 130. You understand? And the reason why I did that is because I need the time taken at that point to calculate the retardation as the body is being brought to rest. Okay? So, retardation as the body is being brought to rest is equals to change in velocity all over change in time, which will be equals to final velocity v minus u all over, or you can call it v minus u over t2 minus t1. You understand? So for this, I'm going to have v minus u 140 minus u is 0. You understand? U is 0. Do you know? Please pay attention. The reason why I'm making reference to this velocity is because you can see the body is brought to rest from this point to this point. So the velocity at this point is what? 140. The velocity at this point is what? 0. You understand? So that's why I have 140 minus 0 all over t2. T2 is what? 130. 130 minus 110. Do you understand? So for this, I'm going to have 140 minus 0. That is 140 all over 20, you understand? So for this, I'm going to have 7 meter per second squared. Do you understand? If you don't understand, reverse the video and listen to the explanation again. Okay, so that is the answer to the second question. Now let us proceed to the third question. We are asked to calculate the total distance traveled during the first 50 seconds. Okay, please, I want to pay attention. The total distance traveled during the first 50 seconds. That is the distance from this point to this point. That is what we have to determine. Now, don't forget, in our previous class, I told you, when we are talking about distance on the velocity time graph, the distance represents the area of the shape. You understand? The area of the velocity time graphs give the distance. You understand? Now, we have to calculate this step by step. You understand? You can see that we have a triangular shape and a trapezium shape within the first 50 seconds of the motion of that body. You understand? From this, the first 30 seconds signifies that is a right angle triangle. You understand? For the first 30 seconds, we have this. That is this. The first 30 seconds we have, and from this point to this point is what? 240. You understand? You can see that this is a triangle. Okay, so we have to determine the area of this triangle and the area of the second one, which is the trapezium. If you pay attention, you are going to see something like this. You're going to see something like this. 20 seconds, and the height here is 140, and the height here is 240. You see, what I'm doing is that I just bring out the shape so that you can know how to calculate it. You understand? I just bring out the shape. You see, from this point to this point is 240. Okay, so you can see we have triangle within the first 50 seconds. We have two shapes. The first shape is triangle, and the second shape is trapezium. You understand? So that is it. Now, to calculate the distance traveled during the first 50 seconds, we have to calculate the area of this, and then add it together. Do you understand? And the area of a triangle is what? Half base times height. So I'm going to have the area of this triangle equals to half base times height. Half base times height. You understand? So for this, we're going to have half base. The base is what? 30 multiplied by 30 multiplied by height. The height is what? 240 multiplied by 240. So for this, we are going to have 30 multiplied by 240 divided by 2. 30, that is 3,600. So that is 3,600 meter. Okay. Now let us calculate the area of this trapezium. You understand? Please pay attention. I told you in our previous class that when we are dealing with the total distance traveled of the velocity time graph, the area of the shape of that velocity time graph give us the total distance traveled. So I've already calculated the area of this triangle, which is what? Triangle OU this. You understand? This triangle, I've already calculated the area. Now let us calculate the area of this trapezium. Do you understand? The area of this trapezium. So the area of this trapezium, I just withdraw it. This is 20, this is 240, this is 140. You understand? So the area of this trapezium is 1/2 a plus b multiplied by h. You understand? 1/2 a plus b multiplied by h. That is 1/2 half. A is the longer length, the longer length of the side of this trapezium. That is 240. So I'm going to have 240 plus b 140. Let me erase this. This is 240, okay? Plus 140 multiplied by h. The height is what? 20 equals to, okay? So if you calculate this, you're going to have 3,800. Okay, so this will give 3,800 meter. Now the total distance traveled in the first 50 seconds is the sum of the area of this triangle and the area of the trapezium. Do you understand? Okay, so the total distance traveled in the first 50 seconds equals to 3,600 plus 3,800. Okay, let me put meter here. Now that will be 7,400. 7,400 meter. You understand? That is the distance traveled in 50 seconds by the object. Okay, so the next question says we should determine the average speed. We should determine the average speed during the same interval as in Roman figure 3. That is the average speed during the total distance traveled in 50 seconds. You understand? Please pay attention. The last question says we should determine the average speed during the same time interval as in Roman figure 3. That is, we should determine the average speed in the first 50 seconds as well. You understand? And speed is what? Distance over time. You understand? So we can easily say that speed. Okay, this is question 1, this is question 2, this is question 3. Okay, let me erase this. So I can do question 4 here. Please pay attention. Okay, question 4, the average speed. You understand? The average speed in 50 seconds. That is what? Distance over time. The distance in 50 seconds is what? 7,400 meter. So I'm going to have 7,400 meter all over time taken, which is what? 50 seconds. Okay, so 50 seconds. So 7,400 meter divided by 50 seconds. That is 148 meter per second. Okay, 148 meter per second. So that is the answer to that question. Trust you understand the solution to the question. If you didn't understand, please let me know in the comment section. Or if you have any question, let me know in the comment section. Okay, so that will be all for this class. In this class, we're going to go over questions on velocity time graph. Okay, let's start with the first question. The diagram above represents the velocity time graph of a body in motion. The total distance traveled by the body is 195 meters. Calculate the acceleration of the body in the section OP of the graph. Okay, we are asked to calculate the acceleration of the body in this section OP. This is point O and this is point P. So we are asked to calculate the acceleration. Now, we are given that the total distance covered by the body is 195. So that's the parameters that were given. S is equals to 195 meters. Okay, now we cannot determine the acceleration of this section without knowing the velocity. You understand? Because when the body starts from rest, it starts from point O. You understand? Then it accelerates. The acceleration would when it accelerates, it got to point P. That acceleration is what we are asked to calculate. But it doesn't just accelerate. It attains a velocity. That velocity is what we need to determine before we can calculate the acceleration. You understand? You know, acceleration is equals to change in velocity all over change in time. Okay, so how do we determine the velocity? The velocity at this point, we need that velocity. You understand? This is the final velocity, Vf. That is the final velocity. Now we need to determine the final velocity that the body attains when it accelerates. Okay, don't forget, in our previous class on velocity time graph, I told you that anytime you are calculating the velocity in velocity time graph is also the same thing as height. You understand? Hello, listen to the explanation again. When you are dealing with velocity in velocity time graph, the height of the graph along the y-axis is also the same thing as the velocity. Are you paying attention? So here, since we've been given the area of the motion, the area of this graph is 195. Are you paying attention? Please pay attention. The total distance is equal to the total area. Are you paying attention? Distance covered, distance is equal to area of the graph. Are you paying attention? Now, if you look at this graph, what is the shape? What shape do we have on this graph? The shape that we have is this is the shape. Now, what is the name of this shape? The name of this shape is known as trapezium. You understand? The name of this shape is known as trapezium. So here we have trapezium. Okay. Now you know that the name of this shape is trapezium. Now, what is the area of a trapezium? Area of a trapezium is equals to, sorry, I'm not really good at drawing, but I want you to understand. That's why area of a trapezium is equals to 1/2 a plus b multiplied by h. You understand? And I told you that when you are dealing with velocity time graph, height is the velocity. You understand? Because the velocity is represented along the y-axis, so the height is the velocity. You understand? So here I'm going to have the area is equals to 1/2 multiplied by a plus b multiplied by vf. You understand? Where vf is the final velocity that we need. Are you paying attention? Now, the area is equals to the distance. You understand? The total distance on the velocity time graph is the same as the area of that velocity time graph. You understand? So area is what, 195 meters. So I'm going to have 195 is equals to a plus b. A in this case, A and B in the trapezium are those parallel sides that can never meet. You understand? If you look at this trapezium, this line and this line can never meet. You understand? Look, this line that you see here and this line, they can never meet. So here, these sides that are parallel to each other are known as A and B. So here we have A and this is B. Now let's go back to our velocity time graph. The A in this velocity time graph is this. So the distance from this point to this point is what? 21. You understand? So here I'm going to have 21 plus, okay, B. B is what? The distance from this point to this point. The distance from this point to this point is what? 11 minus 6. You understand? So that is what? 5. You understand? The distance from this point to this point is 5. And the distance from this point to this point, hello, from this point to this point, that is what? 21. So I'm going to have 5 plus 21 plus 5 all over 2 multiplied by VF. Do you understand? If you didn't understand, listen to the explanation again, okay? Now, here we have 195 is equals to 26 all over 2 multiplied by final velocity. I'm very sure you understand what I'm doing, okay? Now, 26 divided by 2 will give us 13. So I'm going to have 195 is equals to 13 multiplied by final velocity. So divide by 13 to get the final velocity. So the final velocity is equals to 195 divided by 13. That will give us 15, okay? That means 15 meter per second because velocity is measured in meter per second. Now, having gotten the final velocity that we need, so we can easily determine the acceleration of the section OP according to the question, okay? At the acceleration of section OP. Now, acceleration is changing velocity over time. So, acceleration here is equals to change in velocity all over change in time. Acceleration is equals to, now, Vf minus V initial, that is change in velocity. That is the difference between the final velocity and the initial velocity. The final velocity is what? Is 15 meters per second. So here I'm going to have 15 meters per second minus the initial velocity is 0. You understand? So here I'm going to have minus 0 all over change in time. So the final time is what? Is 6. Don't go and use this time. Oh, hello. Don't go and use 21, okay? Because we are asked to calculate the acceleration of the section OP. You understand? So don't go and use this. Don't go and use 21. Use 6. You understand? Because that is the time it takes to accelerate from rest to the point P. Do you understand? So the final time is 6. So I'm going to have 6 minus the initial time is what? 0. So I'm going to have 0. Okay? A is equals to 15 all over 6. Acceleration is equals to 15 divided by 6. What's the answer? 15 divided by 6 is 2.5 meter per second. So acceleration is a meter per second squared. So I'm going to have 2.5 meter per second squared. Do you understand? Okay, now let's say the question now says we should determine the acceleration of the body. That will be 15 change in velocity, which is Vf minus V naught, divided by change in time, 21 minus 0. You understand? So you're going to have 0.71. Do you understand? But we are only asked to calculate the acceleration of the section OP. Do you understand? Okay, so the acceleration of the section OP is 2.5 meter per second squared. Okay, so that is the solution to the question. Okay, let's look at question number 2. The diagram illustrates the velocity time graph of the motion of a body. We are asked to calculate the total distance covered by the body. Okay, now look at this velocity time graph. On this velocity time graph, the total distance is the same thing as the area of the graph. Don't forget. Okay, when you talk about the distance on the velocity time graph, the total area of the graph gives the distance. You understand? So we are given this velocity time graph as the graph that illustrates the motion of the that a body undergoes. You understand? So the area that we have, the area of the shape that we have on this velocity time graph will give us the total distance. You understand? So now let's calculate the area. Please kindly pay attention. Solution. That is question number 2. Now on this velocity time graph, we have three shapes. Hello? On this velocity time graph, we have three shapes. The sum of the area of these three shapes will give us the total distance traveled by the body. You understand? So the first shape is this, the second is this, and the third is this. You understand? So let us take it step by step. Okay? Now, the first shape is this shape. The shape, let me give it a letter. Let's call this shape A, B, C, D. You understand? So the first shape is A, B, C, D. Okay, so here we are going to have something like this. A, B, C, D. Do you understand? If you didn't understand, listen to the explanation again. It's simple, okay? Now, you can see that the shape that you have here, the shape that you have here, what is the name of the shape? The name of the shape is a trapezium. You understand? Having known that the name of this shape is a trapezium, now let us label the side. You can see that from this point, this is small letter, okay? Let me write it in small letter so that there will not be confusion, okay? Now, from this point, this is AC. This should be C and this should be D. You understand? Okay? Now, let us label the side. From this point to this point is what? Is 10. You understand? Because this point is 0.0. Now, the body moves from 0 velocity to 10 velocity. So, from this point to this point is 10. So, I'm going to have 10 here. From this point to this point is 5. You understand? That is 5 seconds. So, I'm going to have 5 here. From this point to this point, if you trace it to the velocity side, you are going to discover that it is 20. Are you paying attention? Hello? This represents the height, and along every graph, height is measured on the y-axis. You understand? So if you trace this from this point to this point is 20. How do I know? I trace it to the corresponding value along the y-axis, which is the velocity. You understand? So here is 20. So this side will be 20, and AB. Now, we have labeled the side. You understand? We don't have any value for this side, which is AB. That's not the problem, okay? We have gotten all we need to calculate the area of the trapezium. You understand? And area of the trapezium is given by this formula. Area is equals to half multiplied by A plus B multiplied by H, where A plus B is the sum of the parallel side of the trapezium. Parallel lines are lines that cannot meet. You understand? So you can see that this is one, this line and this line cannot meet. That means that they are parallel side. You understand? So here we are going to have area is equals to 1 over 2 multiplied by 10 plus 20 multiplied by 5. You understand? Height is the 5. The height is the 5. You see, you can redraw this trapezium as this. Hello? You can redraw it like this. We're going to have something like this. We're going to have something like this. Where, please pay attention, where the longest side is B, D, then we have A, and we have C. You understand? So you can see, you can redraw it like this. You can see that this is exactly how a trapezium look like. You understand? So you having redraw it like this, you can easily determine the A. The A is the parallel side, which is this and this. That is 10 and 20. You can see this will be 10 and this will be 20, and CD will be the height, which is height. You understand? And with this, you can easily determine the area of the trapezium. Do you understand? So now, all you have to do now is that you just have to add 10 and 20, that is 30. 30 divided by 2, that is 15. 15 multiplied by 5, that is 75. You understand? Let me erase this. So the area is equals to 30 all over 2 multiplied by 5. Okay? That is 15 multiplied by 5. 15 times 5 is 75. So this is 75. Now, because we are dealing with distance, so we are going to put it in meter, okay? So now, that is the first section on this velocity time graph. Now, let us proceed to the second section. On the second section, we have B. And the shape is like this. This is how the shape look like. You can see. See, you have to pay attention to the shape. This is not a square. You understand? It's a rectangle, okay? You can see that the lengths are not the same. The length of this and this are not the same. Now we have, okay, let us call this one as well, letter A, B, C, D. Let's call this one E. Let's call this one F. Okay, so we have B, D, E, F. Okay, now please pay attention. You can see that the shape that we have is a rectangle. Area of the rectangle is what? Length times breadth. Okay, so let us label the side. BD is, what is the length of BD? The length of BD is what? Is 20. You understand? I've already explained it. The length of BD is 20. And how do I got 20? I trace the height from this point to this point. I trace it to the velocity side. I trace it to the velocity side. And what is the corresponding value at that point is 20. You understand? So let me even redo this. This is where it should be. So the corresponding value of the velocity at that side is 20. So the length of BD is 20. So this side is 20. And now DF is what? DF is what? DF will be 10 minus 5. Are you paying attention? Hello? The distance between this point to this point will be 10 minus 5. 10 minus 5 is what? 10 minus 5 is equals to 5. So the distance between this point to this point is 5. How do I got 10? The final distance is this. Okay, the final time is 10. The second, the initial time is what? Is 5. 10 minus 5 is 5. So the distance between this point to this point is 5. Are you paying attention? So DF will be 5. Now, we've gotten all we need to calculate the area of the rectangle. So area of the rectangle is equals to what? Length times breadth. Okay? The length is 5 and the breadth is 20. So here we're going to have 5 times 10, 5 times 20 is 100. So here we have 100 meters. That is the area of the shape. That is the area of the rectangle. Okay, now let us proceed to the last shape. The last shape, we have a triangle. You understand? And let's just draw it. Let's draw it out. Okay. Here we have something like this. We have something like this. And you can see that will be EF. Let me call this place G. Okay, EFG. E, F, and G. Okay. Now, from this point to this point, the difference is what? 15 minus 10. 15 minus 10 is what? That is 5. So the distance between this point to this point is 5. That is the time. You understand? So the time taken from this point to this point is 5. Now, that means that FG is 5. And EF. EF is also the same thing as is always the same thing as BD, you understand? So that will be 20. So here I'm going to have 20. So area of a rectangle is half base times height. So area is equals to half multiplied by base multiplied by height. You understand? So area is equals to 1/2 multiplied by base. The base here is 5 multiplied by height, which is 20. Okay, 5 times 20 is 100. 100 divided by 2 is what? Is 50. So here we have 50 meter. Do you understand? Okay, so having gotten all the area of the shapes that we have on the velocity time graph, don't forget the area is also the same thing as the distance. You understand? So the total distance is equals to, the total distance is equals to the sum of all the area. You understand? So let us proceed. We are going to have the sum of this area, which is 75 meter, area of the trapezium, plus the area of the rectangle, which is 100 meter, plus the area of the triangle, which is 50 meter. Okay, 50 meter. So the total distance is 75 meter plus 100 meter plus 50 meter. That will give us 225 meter. You understand? So the total distance is 225 meter. So that is the solution to that question. If you have any question regarding what we've learned in this class, let me know in the comment section. Okay, in this class we're going to go over questions on velocity time graph. Okay, let's start with the first question. We are given this graph. This graph represents the velocity time graph of a body. We are asked to calculate the distance covered in the first 20 seconds. Okay, don't forget, in our previous class I told you that when we talk about distance on the velocity time graph, we are referring to the area of the graph. You understand? Area of the shape on the graph gives the distance of the body that undergoes such velocity time graph. Now, if you look at this graph, you will see that the area of the whole graph is what? Is a trapezium. You understand? The shape of the whole graph is a trapezium. This is how the shape look like. You understand? But we don't need the area. Okay, let me just put it. Area is equals to distance. When you are dealing with velocity time graph, just pay attention to this. Area of the shape is equals to the distance of the body. You understand? Okay. Now the total area, the area of this the area that we have on this velocity time graph is a trapezium, but we are not asked to determine the total distance. We are asked to calculate the distance that the body covered in the first 20 seconds. You understand? And the first 20 seconds is from this point to this point. Is from this point to this point. You understand? Because the time is along this is the time and this is the velocity. Okay? Now the first 20 seconds is from this point to this point. So the shape now becomes like this. You understand? Let me call this point A, B, C, D, E. You understand? Let us call this F. Normally, the total shape is what? A trapezium, which is A. Okay, no, which is A, B. Okay, we have something like this: A, B, C, we have D, we have E, and we have F. But because we are only interested in the distance that the body covered in the first 20 seconds, so this is the shape that we need: A, B, C, D, and E. You understand? This is the shape that we need. Hello? Because this is the first 20 seconds. Now, having identified the shape, the next step is that let us label the shape. You understand? So from this point to this point is 20. So from A to E is what? Is 20. From C to E is what? Hello, pay attention. From C to E, this distance that you see here is, just trace it to the velocity side. That is 4. So from C to E it is 4. Now from B to C, which is the shape from this point to this point, please pay attention. It's simple. Okay, you see what I'm doing is that we are asked to calculate the total distance that the body traveled in the first 20 seconds. The time taken for the whole journey is 25 seconds, but we are only interested in the total distance that it traveled in the first 20 seconds. So now the first 20 seconds is from this point to this point, which is what? 20. So the shape along the first 20 seconds is also a trapezium. You understand? That is why I dragged it out. You understand? Now, the distance from this point to this point, which is from A to E, is what? 20. You understand? That is the distance from this point to this point. That is 20. And the distance from this point to this point, that is 4. Because when you trace it from this point to this point, you trace it to the velocity side. The velocity is represented along the y-axis. You understand? Hello? The velocity is represented along the y-axis. So if you trace it to the velocity side, you are going to discover that the corresponding value of the velocity is what? Is 4. So from this point to this point, which is E to C, is 4. Now, the next side that I need is what? From this point to this point, which is BC. The distance of BC is what? 20 minus 10. You understand? 20 minus 10 is what? 10. So the distance from this point to this point is 10. I'm going to show you how I got it. Do you know that we have 10 here, we're going to have 10 here, we have 20 here, we're going to have 20 here. Now 20 minus 10 is what? 10. Do you understand? That is how I got the distance between B and C. Okay? Now I'm going to have 10 in this place. Now I've gotten all the size that I need to determine the distance that the body traveled in the first 20 seconds. All I need to do is that just take the area of this trapezium. You understand? And the area of the trapezium is given by this formula. Area is equals to half A plus B multiplied by height. A and B are the parallel side of the trapezium that can never meet. So the first parallel side is what? Is 20. So I'm going to have area is equals to 1 over 2 A. A is 20, then B is 10. You understand? When we talk about parallel, those sides can never meet. You understand? Parallel lines, you remember in your geometry, parallel lines, they can never meet. So here we have 20 plus 10. 20 plus 10 multiplied by height. In this case, height is 4. So the area is equals to 1 over 2 multiplied by 30. 20 plus 10 is 30. 30 multiplied by 4. Here I'm going to have 15 because 30 divided by 2 is what? Is 15. 15 times 4 is what? 60. So the area is equals to 15 multiplied by 4 is 60. So I'm going to have 60 meters. So the area that the distance, now you change it now. The distance is equals to S. S is equals to 60 meters, which is the distance that the body covered in 20 seconds. Do you understand? Okay, so that is the solution to that question. Now let's proceed to the second question. Okay. Okay. The figure shows the velocity time graph of a car which starts from rest and is accelerated uniformly at the rate of 3 meters per second squared for 5 seconds. It attains a velocity which is maintained for 1 minute. The car is then brought to rest by a uniform retardation after another 3 seconds. Calculate the total distance covered by the car. Now, they gave us this velocity. The velocity is not labeled, you know, they didn't represent, they just gave us the parameters, they needed information that we need to, they give us a typical representation of how the velocity time graph will look like. So we are asked to calculate the distance. Now, let's start our solution. Please, I want you to pay attention, okay? All you have to do is just be attentive. Let's start with the first parameter that we're given. This figure shows the velocity time graph of a car which starts from rest. Now, from rest simply means it starts from this point and it accelerates uniformly at the rate of 3 meters per second squared for 5 seconds. So, when a car accelerates, the velocity increases. You understand? Hello? Acceleration tells us how fast the velocity of an object is changing. Okay? So, when a car accelerates, the velocity of that car changes from 0 to it has a significant velocity. So when this car accelerates for 3 meters per second squared, it attains a velocity. The velocity we don't know, but the velocity should be here. You understand? It attains this velocity. This is the velocity that is attained. We don't know it. Let us represent it as VF. Okay? Now, that is the time that is used to accelerate from rest is what? Is 5 seconds. So here is going to be 5. Okay, Now, the question says it attains a velocity which is maintained for 1 minute. Now, our time is represented in seconds, so we are going to use seconds, okay? Change 1 minute to seconds. 1 minute is equivalent to 60 seconds, you understand? So, it maintains that velocity for another 60 seconds. So, that means that from this point to this point, the time is 60 seconds. So, let's just trace it. Now, from this point to this point, the time is 60 seconds. That means that from this point to this point, the time will be what? 65. Hello? From this point to this point is 5. From this point to this point is what? 60 seconds. That means that from this point to this point, the time will be 65 seconds. Do you understand? You must learn how to interpret question, okay? That's what I'm trying to explain. That's what I'm trying to do, okay? You see, it accelerates at the rate of 3 meters per second squared for 5 seconds. That is the representation here. It attains the velocity. This is the velocity. Now, it maintains this velocity for another 1 second. That is what? Another 1 minute. That is what? 60 seconds. So, that means that from this point to this point is what? 60 seconds. Now, if from this point to this point is 60 seconds, and you know that from this point to this point is 5 seconds, that means that the total distance from this point to this point is what? 60 plus 5. That is 65 seconds. You understand? So, let me erase. I'm coming. Let me erase this. Okay, so from this point to this point is 65 seconds. Now, let's proceed to with the question. The car then is brought to rest by a uniform retardation for another 3 seconds. Don't forget, in our previous class I told you retardation is negative acceleration. It is the kind of acceleration that brings the motion of an object to rest. You understand? Okay, so when it retards, after undergoing retardation for another 3 seconds, it is brought to rest. So that means that the seconds, the time taken from this point to this point is what? Is 3 seconds. So if this is 3 seconds, that means that from this point to this point is what? 65 plus 3. That means I'm going to have 68 seconds. You understand? Okay, I'm just trying to teach you how to how you are going to get the parameters that you need to calculate the total distance, because if you didn't have all these parameters, it's very, very important for you to calculate the total distance. And this is a JAM question. You understand? It's a UTME past exam question. Okay, so now we are done with the interpretation. You understand? Now, how do we calculate the total distance? The distance on the velocity time graph is equivalent to the area of the velocity time graph. You understand? Now, if you look at this shape, what area do you see? What is the name of the area that we have on this velocity time graph? The area is, what's the shape rather? The shape is trapezium, you understand? So, let me just label it A, B, C, D, E, F. You understand? Okay? Now, and the area of a trapezium is given by this formula. Area is equals to half A plus B multiplied by H. You understand? And I told you height on a velocity time graph is the velocity. You understand? Because the velocity is measured along the y-axis. You understand? The velocity is measured along the y-axis. So the height on the velocity time graph is the velocity. All you have to do is just to trace that point to the velocity, which is the y-axis. You are going to get the corresponding value. That corresponding value there is the height. Now, we know that A and B are the parallel side of the trapezium. Let me bring it out. Okay. This is the shape that we have. Okay. Look. This is A. This is B. This is C. This is D, this is E, and this is F. You understand? From this point to this point is what? 68. Okay? Now, from this point to this point is what? 60. Okay? Now, this is A. Hello? This is A. This is B. Now, we need the H. The H is the velocity. The velocity that we need is VF. You understand? The height is the velocity. The velocity that is attained, that velocity is what we need. Now, how do we determine the velocity? Because if you don't know the velocity, we cannot determine the area. You understand? Because area is 1/2 multiplied by a plus b multiplied by height, and height is the velocity. So we need the value of the velocity. Now, we are given an information in that question that the body accelerates from rest as an acceleration of what? 3 meters per second squared. So now acceleration is equals to 3 meters per second squared. Now, when it accelerates, it attains the velocity. That velocity, we need to determine it. That velocity is Vf. Because from our previous class, you know that acceleration is change in velocity over time. You understand? So here, acceleration, which is 3 meters per second squared, is equals to change in velocity, that is V all over T. Hello? You just have to pay attention. What I want to do is that I need to determine the velocity, okay? The velocity that it attained, the velocity that the body attained when it accelerates at the rate of 3 meters per second squared. And acceleration is what? Velocity over time. So here I'm going to have Vf all over time. Now 3 is equals to Vf all over T. T is 5 because it accelerates at 3 meters per second squared. It attains the velocity. The time that it's used to accelerate at that velocity, the time that it's used to undergo acceleration is what? Is 5 seconds. You understand? If you pay attention to the question, you are going to understand what I'm doing. Okay? So here I'm going to have 3 here. So all you have to do now is to cross multiply. Oh, it is 5. So I'm going to have 5 here. So Vf is equals to 5 multiplied by 3. The velocity that it attained is what? 15 meters per second squared. Okay? Oh, sorry. 15 meters per second. The velocity is a meter per second. Now, we cannot determine the area. I mean the distance. So the distance is equals to 1/2 multiplied by 68 plus 60 multiplied by 15. I'm very sure you understand how I got this. Look, the first parallel side is 68, the second is 60. The height, which is the velocity, is 15. That's how I got this, okay? So S is equals to 1/2 multiplied by 60 plus 68. That is 128. 128 multiplied by 15. Okay? Now, 128 divided by 2, that is 64. Okay? So here we're going to have S. Okay? S is equals to 64 multiplied by 15. That is S is equals to 960. That is 960 meters. Do you understand? If you didn't understand, you have to listen to the explanation again, okay? So that is how to solve question on velocity time graph.